Okay, so we're going to do part 2, more square root stuff. So I want to start out by just reviewing a couple of problems from yesterday. So we'll start out by doing a couple of these. And we did a couple of these on our study guide this morning. But let's just practice a little bit and then we'll move on. Okay? So maybe I can do like, is my thing working? Zoom in. Oh, wait. Is that better? Okay, so how about if I show you like number this one? I think 98 is 49 times 2. So since 98 is 49 times 2, I can split this up into 49 times square root of 2. And of course I know the square root of 49 is 7, so this becomes 7 square root 2. And anytime you find a perfect square here and you simplify it to like a whole number, that's what they mean by simplify. We'll just do maybe one more here. Well, let's try a quotient one. This one we could write as square root of 11 over square root of 25. And of course, square root of 25 is 5, so we could write this as square root 11 over 5. So those are some of the properties we learned about yesterday. So let's move on now to new stuff. Now we were talking about one problem yesterday where we eliminate the denominator. And that one eliminates square roots from the denominator. So that one's an easier one. And we did that one yesterday, but this one's a little bit harder. Okay. We use what's called the conjugate, and you'll understand what the conjugate is a little bit better when we do the quadratic formula later on in this chapter. But what you want to do to get rid of this, we kind of use this idea. And see if you understand this idea here. I'm going to switch to this paper right here and show you an idea. When we do a squared minus b squared, it's equal to a plus b and a minus b. Now, you know from multiplying this out that this gives you a squared, and then it gives you a minus ab, and then it gives you a plus ab, and then it gives you minus b squared. You see? So these disappear. Now the nice thing is that what ends up is this. Now this gives us a clue on how to get rid of square roots. Because if you have a square root 5 here and a square root 5 here, when you multiply them, you're squaring them. And I've showed you before, anytime you multiply a square root times itself, you get the number on the inside. You get the number on the inside. Again, that's equal to the square root of 25. That's equal to the square root of 5 squared. And the index on a square root is a 2. And they're inverse operations, so they cancel. So you get 5. Well, so that's this little idea here is the idea we're going to use to get rid of square roots. And it just turns out that when we get to the quadratic formula, these are often called conjugates. And you'll notice one of these plus, one of these minus. So that's the secret. Let me show you now how the secret works. To get rid of this square root 2, you multiply by the conjugate of this expression right here. And the conjugate in this case, I'll show you once and then I think you'll get it. It's 7 minus the square root of 2. You see? But you have to do that in the numerator as well. 7 minus the square root of 2. Now, I know some of you guys can't see that, so I think I'll raise it up a little bit higher. Now, notice the pattern. I was just showing you, this is like A plus B. This is like A minus B. And see, so that's the idea. The way you determine what to multiply by is you use the conjugate. And so one of these will have a plus, one of them has a minus, so it's going to be this little pattern right here. It's like the difference of two squares. And notice what happens when we multiply this out now. In the denominator, I have 7 times 7, which is 49. And then I have 7 times the square root 2. But that's negative 7 square root 2. Okay? And then this one gives me the positive 7 square root 2. And then this one times this one gives me minus square root of 4. Okay? And the top, I had a 3 sitting here. So I'm going to have a 3 times the 7 gives me 21. And then 3 times this square root here, negative 3 square root 2. Now, this simplifies quite a bit down here, though. These are opposite in sign, so they subtract off. And the square root of 4 is actually 2. So down in the denominator, we actually have 47. Because 49 minus 2 is 47. And then up in the numerator, we have 21 minus 3 square root 2. Okay, now that you've seen how to do this problem, that's how you do it. That's how you rationalize the denominator. I want you to go ahead and do number 6 now on your study guide. Everybody do number 6. I'm going to pause the video for a moment. Okay, so number 6 on your study guide. Just real quick, I'll see if you guys get the same answer I get. Oh, whoops, sorry. See if I can get this here. Okay. So I have 2 square root 3 plus 5. Okay, so what I want to do is multiply this by, what do we want to try here? Did you guys try like square root 3?
Negative 5.
Minus 5. Okay, that looks like the right winning plan. Again, one of these is going to be plus, one of these is going to be minus. Reminds us of the difference of two squares. But you also have to multiply the top by the same thing. Okay? So what would happen? Well, as I multiply these out here, I'm just going to use the FOIL method. And after you do this problem, you can probably do it a little bit faster on your own. But square root 3 times the square root of 3 is 3. And so that one's gone. Now, when you do this one, you're going to get minus 5 square root 3. And then when you multiply this one, you're going to get plus 5 square root 3. And those are opposite in sign, so they just drop out. And so then you have 5 times a minus 5. That's minus 25. Okay? And if, yeah?
So the square root of 3
times the square root of,
multiply the square root of 3, is it square root of 9 or?
square root of 9, which is 3.
Oh.
Well, I could show you that again. Square root of 3
Yeah, I get that.
times the square root of 3. That's going to be equal to the square root of 9, right? Which is equal to the square root of 3 squared. Now the index on a square root is a 2, and these are inverse operations. So this 2 cancels off with that 2, leaves you at 3. If you want to just remember, anytime you multiply a square root by itself, you just get the number that's on the inside of the square root. It'll probably be faster. It's a little shortcut I learned a long time ago. So in any event, the denominator here becomes 3 minus 25. I think that's negative 22, right? Mm-hmm.
Yeah.
And then notice what we have up here. We had 2 times this expression, square root 3 minus 5. Well, hey, you know what? That's an even number up there. Why don't we just cancel this? We can do this little trick. We can divide this one by 2 and divide this one by 2, right? In other words, this can cancel off with that. And that gives me negative 11 down here. And then I have square root 3 minus 5. Okay, so you've seen now how to deal with these square roots that are in the denominator. Oh, that was ugly. Anyhow, those take a little bit of work, and you'll want to have this example. That'll help you when you do the book assignment. I'm sure there'll be a few more of these on the book assignment. Okay. Okay, so let's go back to the PowerPoint now and continue. Oh, let's back up. Hold up. I think what we should do before we should move on is maybe a couple more of these. How about number 9? I'll go ahead and do number 9. And then I think I'll do number 14. Okay? This one will go up here. Okay? We could rewrite this as the square root of 6 times the square root of 5. Now, once again, in mathematics, we want to follow the little rules that say you can't have a square root in the denominator. It's not a super strict rule, but usually when we're communicating, want to finish off our answers here. Typically, if you don't do this, you're going to lose some credit for not simplifying. The directions here were to simplify. So, okay, so anyhow, what we do is we multiply by the conjugate, or we multiply by the same thing. Square root 5 here, square root 5 here. And so this gives us square root of 30 up here. Did it freeze?
Frozen.
Good piece of junk. I'm getting really tired of this, already doing this. It's like, I think it has to do with internet connectivity or something. Okay, sorry about that. Okay. Is it better? Okay, so we end up with square root 30. And square root 5 times square root 5 is simply 5. And that's done now. That's simplified. Now this one, on the other hand, what we want to do is multiply by the conjugate. And so we're going to multiply by 4 minus the square root of 11. And you have to do that in the numerator as well. Well, you need to keep quiet, please. All right. So multiplying this out, you get 4 times 4, which is 16. Now, keep in mind, the middle terms are going to subtract off. 4 times that one, 4 times this one. That's going to give you the 0. And then finally, you're going to do square root 11 times square root 11, which is simply 11. Okay? And so then in the numerator, we had, what, a 2 sitting there? You got to multiply this also. So you're going to get 2 times 4, which is 8, and then minus 2 square root 11. And of course, we'll go one more step. 16 minus 11, of course, is just 5, right? Then you have 8 minus 2 square root 11. Alright, so some of these take a little bit of work. Alright, I don't want to bore you too much doing more of those. Well, now we're ready to start solving equations using square root method. Now you'll notice that not all equations factor so nicely. In fact, some equations don't even have a middle term. So when you have ax squared plus bx plus c equal to 0, what we like to do is this method. We factor it. And then we can use the principle of zero products. That's what we've been doing. But not all these quadratics even have, like you'll notice this equation up here, it doesn't even have a bx term in there. How do you factor it then? Well, see, so what we definitely have to be able to do is we have to learn different tools on how to solve this one. And that's kind of what we're doing. We're going to learn how to solve this by using the square root method. So
Nancy's saying to subtract 5.
she's right. Subtract 5 here. Subtract 5 here. And that gives me 3x squared is equal to what? 35? No? 30. 36? 36. And then we divide by 3 here. Divide by 3 here. I get x squared is equal to 12?
Yep.
And then I take the square root here and a square root here. You see, so now keep in mind when I'm solving for x, I actually have to put plus or minus. And that was part of my discussion yesterday. When you have r squared is equal to 16, there's two answers that work. R equals 4 works, and r is equal to, whoops, wrote that backwards. Sometimes I think I'm dyslexic. Okay, so r is equal to negative 4. Well, so anyhow, because of that, because there's always two answers that work, anytime we take a square root and we're solving for x, we have to put plus or minus here. But this is equal to the square root of 4 times the square root of 3, right? And we know the square root of 4 is 2. So we could write this as plus or minus 2 square root 3. Okay? Now, I think it would be a good time, now that you've seen that example, I want you to do number 7 and 8. 7, 8 on your study guide. So again, I'm going to stop the video right here. I want you to practice this right now. Do number 7 and 8 on the study guide. Okay, so we did these now. Everyone should know how and feel a little bit more comfortable doing those. Let's go back to the lesson now. So, here's another one. Okay. Now, I'll show you what some bozos do, but if you're smart, you can make your work a lot easier if you're smart here. You see, some people see this exponent and they just automatically start multiplying everything out. Right? Why not be smart here? Here's what I mean by being smart. Get rid of this 1/5 first. We just saw how to do that on the previous problem, right? If we multiply this side by 5, multiply this side by 5, then that gets rid of the 1/5. And so now what we have is z plus 3 squared is equal to 35. Okay? And so now we can use the square root method. Remember, that's a square up there. So the inverse operation of a square is its square root. So if you use the square root here, alright, and you use a square root here, now remember, anytime you're solving for a variable, when you do your square root step, you need to put in a plus or minus here. And so the square, the index is a 2, you have a square here, so those cancel each other, right? So when this cancels off with that, you get z plus 3. And then over here, you have plus or minus square root of 35. Okay? Well, there's only one thing left to do. We need to solve for z, so we can move the 3 over by subtracting, right? I'm going to change the colors. I'm tired of that. Go to nice blue. Okay, so I'm going to subtract 3 here. Subtract 3, and there's an equal sign right there. And so this gives me z is equal to negative 3 plus or minus square root 35. All right. Let me just do this. You can see the whole process. Okay, let me just look on your study guide and see if you have one of these on your study guide. Oh, no, we don't. Okay, there's only one last type of problem we need to talk about, and those have to do with the application problems. So, let's take a look. You know, if I were you, I would copy this problem on your study guide. Why don't I give you a minute to do that? Just so that you can have that to study from to help you on your homework assignment. I'm going to pause this for continue. Okay, so here's an equation that comes up, and you can solve this equation often by using the square root method. So it has to do when you're dropping objects. And by the way, you may have to use some equations from your book. So if you see an application problem, look in your book at like example 3 or 4 or 5 or whatever, example 5 or so. Might have the equation that you need to solve the problem. Okay? And so this is just one such equation. Has to do with when you drop an object, what is its height going to be after so much time? Like, let's say, how come my pen's not on? Come on. So here's a typical example where a ball is falling. And as it falls, it gains speed. And as it gains speed, it covers a greater amount of distance. So in the first second, it goes here, and it's falling much faster, right? So you'll notice this equation looks like a graph. If you look at the graph here, what does it look like? And hopefully you're saying, well, hey, that looks like a parabola, right? Why did that freeze? Kind of weird. Well, the computer's doing some weird things today. I think we're in the twilight zone. Okay, so anyhow, there's this equation right here. Now, let me explain how that subscript works. You guys listening so you understand this? Pay attention so you get it. When you have a stopwatch and everything starts, we say time is equal to 0. And that's what that 0 stands for. It means the initial time. The initial. If you haven't seen this word much, and that's what it means. It means the starting time. The initial time is when time is equal to 0. Okay? So what you're asked to do is to figure out the height when time is equal to 0. Well, if you go back to this picture here, the height initially was 200 feet. So apparently these painters are up there and they dropped something. I want to find out how long it takes to fall to the ground. By the way, my friends, I've impressed many a lady when I've gone to Palouse Falls and they ask me how high those falls are. You can also drop a rock, start your stopwatch, figure out how long it takes for the rock to hit the ground, and you count quickly in your head. Oh, that was 4.5 seconds. Multiply it by 16 and square it or whatever, and then you have the answer. You never know. You might impress your date if you memorize this equation. Or she might think you're a nerd, which will make her even more excited, because nerds get paid more money usually. Think of Bill Gates. He's a nerd too. Okay, joking aside, that's why they put in the 200 right here for the initial height. Now here's the thing that people don't get. What's the height when the ball hits the ground? Now this is so simple it almost tricks people. The height when it hits the ground is 0. That's why you put a 0 right here, my friends, and then you can solve this. You have 0 minus 16 t squared plus 200. Okay, now since this term is negative, I think we'll move it to the other side and it'll become positive, right? So I'm gonna do some algebra real quick. If I add 16t squared here, I add it over here, then I end up with 16t squared is equal to 200. And then I divide by 16 here, divide by 16 here, and sure enough I get t squared is equal to, and now I'm just going to use my calculator because I can't do those big numbers in my head. 200 divided by 16 is 12.5. Now, this is not a common square root here when I go to this next step here. I'm not going to know this one off the top of my head. So this type of problem I do in my calculator, and when I do that in my calculator, I get t is equal to plus or minus, and we already did it down here. It takes about 3.54. So if you plug that in your calculator, you should get 3.54. However, in this case, does it make sense to have a negative time?
No.
No. So in this case, the negative does not make sense, so we take that one off. Okay, because time equal to 0 was the initial time. So t equal to negative 3 was about 3 seconds before he dropped it, right? He hadn't dropped it yet, right? So I hope that makes sense. So only a positive answer makes sense here. So a couple things when you're using this equation. When something hits the ground, it's 0. Okay? And the h sub 0 here stands for the starting height. So my friends, if you have an application problem on your homework, you might use this equation. And I think that's it for now. Huh? There's another problem there. We're going to stop everything right here. Alright. Okay.